Hello friends, welcome back to the tutorial series of Object Oriented Programming in PLC. So in this particular tutorial, I will be going through two topics, which is encapsulation and the inheritance. So before getting started, let's go with some recap what we have done in the previous video. So basic, we have learned about objects, classes, how class and function blocks are equivalent to each other. So both are UDTs, both are called via instance object, and both consume memory. So this is the basic. Now let's go to the main topics. So when we are talking about object oriented programming, so it has basically four pillars, which are encapsulation, inheritance, data abstraction, and polymorphism. So without this, there's no meaning of object-oriented programming. So let's get started with the encapsulation. So what exactly is encapsulation? So if you're seeing, as the name is providing, it is a kind of capsule. Capsule means the whole code and the data are getting wrapped into a single unit. So like the function block which we create, in that one we define the variables and we also define the code. So that is we are calling as an encapsulation, where we decide what we want to expose and what we don't want to expose. So basically we can make everything private, just as you are seeing in the first example, fb sensor underscore one, nothing is shown. And the second example, we are providing as a getter and the setter. So this is what we do in the IT side also. So I have just given an example here where variables are defined with private and the getter and setters are defined, and then we are calling it in the main program. So let's go and see how exactly we can do the same thing in the PLC. So I'm using here the CoDeSys environment, which supports object oriented programming. So if you see here, we have a defined FB sensor. Okay, so first let's go inside the FB sensor block. So let me go inside. So if you see here, we have different variable type, correct? So var input, var output, and var. So think it like var input are the setter. So it provides, it is exposed to the outside world, and from here we receive the values. Var output is the getter, which is providing output to read the value, and var are the private variables which are not exposed. So those are local variables. Okay, we define here some code, we write some code here. So this is one encapsulated function block. Okay, now if we see here, only the variable which we have defined in the var input and var output are shown in the blocks, whereas if you see the fb sensor underscore one, everything is private. So let me now load the code. And yeah, so once we get online, let me start. Okay, so now let's so this is kind of a scaling block which I've created. So let's give the engineering max value, engineering min value is there, and let's set the AI one. So the analog input which is coming as a count, let's set that particular variable with some value. So once we set it, we will get the output. Okay, so what exactly it is doing? So we have the three variable to set, we are setting it, and we are getting the output from the block. So if any of the variable we change, based on that the output will change. So all the logic inside this is not exposed, it is getting executed inside. Let's see the same thing in the IT side. So this is a C++ program. Okay, So same thing we also do in the IT when we are writing anything in the C++, C or Java, Python, C sharp, anything. So here also, if you see, I have defined here in a similar manner the variables, the getter setter, and calling that in the main, created an instance. Okay, and from that instance we are setting the values. Okay, and once we set the values and run the code, it will provide me the output. So let me run the code. So if you see, we get the output, correct? So this is almost, if you see both the structure, how exactly both are getting executed. So both are getting executed in a similar fashion. Okay, now if I change the value again, I will get some different output. So there are private members, there is getter setter, which is like var input and var output, and then we run the code and we get the value. So this is what exactly the encapsulation is. So we are using it in the PLC, but we are calling that only as a function block. We treat it only as a function block, but it is defining one of the concept of the object oriented programming, which is encapsulation. So this is how we utilizes that concept and use it in the PLC code. So encapsulation is nothing but just utilizing the whole code in one block and what data we want to expose. Okay, so let's start the second concept, which is inheritance. This is one of the main concept in the object oriented, and it plays a major role, which normally we do not use in the PLC coding. So what exactly do it do? So it provides, or it is a procedure in which one class inherits the attributes and method of another class. So if you see the name itself, inherit means we inherit some property from our parents, correct? So that is, consider it as a classes. Okay, so there's one class which is a parent class, which has some defined methods, attributes. Okay, now the same attributes can be utilized by different uh, objects or different classes. So for example, we have a main class called as a car. Now car has different functionality, and all the car has almost same kind of functionality like acceleration, brake, uh, gears, correct? But apart from that, they have their own properties also. So few of the things get inherited from the main class, which is the car. Now each car has their own individuality also, which is like the acceleration speed is faster, they have a different colors. So this is how exactly we do. So the class from where we inherits is the parent class, and the class which inherit from the parent is the child class. So if we take the example of the OT world, which is like a sensor. So sensor is what? Sensor is something which senses uh, the process parameter. Now there can be a flow sensor, there can be a pressure sensor, there can be a temperature sensor. So they have one common functionality, but they also have their own properties. Like pressure sensor can sense only pressure, temperature will sense temperature, and flow will sense flow. Okay, so let's see exactly how it get incorporated into the PLC code. So when we read the data from any of the sensor, okay, first thing what we do is we do a scaling in the PLC code. So let's go to the PLC part. So as we have seen, we have a FB sensor which is doing the scaling, which has its own properties, scaling details, scaling logic is there. Now the same, if for example the pressure, temperature are having just for the scaling purpose, then we can directly call them. But for example, we got a requirement that Inside the pressure sensor, we need a different unit support, multiple unit. So for example, pressure should support psi, bar, and millibar. Temperature should support degree Celsius, degree Fahrenheit, and Kelvin. Okay. Now what normally we do as of now? We will create another function block, or which will have the exact requirement for the pressure. For example, the FB sensor block, we will copy it and create another function block from the FB sensor and name that as a pressure sensor, and another function block and name that as a temperature sensor. So this is just a one way of doing. We can also write directly into the FB sensor, go give the condition that if selection is temperature, the temperature logic should work. If the selection is pressure, then the pressure logic should work. So normally we create different blocks. So for example, if you're seeing, I've created a pressure sensor block and I defined there a set unit, and given that as an integer, that if this particular values are set, if 0 is psi, then 1 is bar and 2 is millibar, and I'm writing the code for that particular section. So set unit is 1, then convert with bar. If set unit is 2, then convert it as a millibar. Okay. So what we did, we duplicated the code here. Basically same thing we will do for temperature. We will duplicate the code for that also. So it has now the code of FB sensor also, all the variables of FB sensor also, and the extra code which we need it specifically for pressure and the temperature. So this is normally how we write as of now. So most of the time we write like this, in by creating multiple function blocks and then calling those function blocks into the main routine and doing the logic part. So this is not the code reusability. I already have one code, but I'm not reusing it. I'm copying it and creating another similar kind of codes. Okay. So what issue we have faced, that if for example I have to change some of the things for the scaling part only, okay, then I have to go and change in all the blocks. But does the functionality changes? No, functionality doesn't changes. Functionality what we want to get, we are getting it. But only the thing is, the maintenance of the code will become heavier. So if we see the functionality part, I have connected all the variables, and let's do it also for the temperature part. So for the pressure and the temperature. So let me create the variables for the temperature. Yeah, so all the variables I have connected, the output is connected now. Now let's create the same kind of blocks using inheritance. So let me create one more project here itself, and let's change the function block of pressure by extending to the FB sensor, and now remove all these variables which are defined here, which are also there, which are the duplicate basically, and remove this logic. Okay. And in order to call the in the inheritance, we use a super function. Okay. Same thing we will do for the temperature. We will extend it to FB sensor. Extends means it is inheriting the another class here. Okay. And super function is used to call the main class, the parent class. Okay. So let me make this as a active application, and let me, so if you see, I'm just comparing the memory part. So memory is almost equivalent. There is no difference in the memory consumption here till as of now. Okay, so let's go to FB sense. Okay, here in the ladder logic we have already defined the pressure and the temperature. Mapped, all the variables are mapped. Okay, so if we see the FB sensor, okay, so it has only all the functionality which is needed for the scaling part. So let me change here only the one value of the raw max, and it get applied to all. I don't have to go and change everywhere, correct? But if I go to application, another application set that is active, let's download it. Okay, so it is downloaded. Let's go into run mode. So if you see the functionality part, functionality remains same. So in both here, when I'm changing the uh, min max and changing the value and changing the unit, the output is getting changed, correct? So the functionality what we wanted remains same. There is no change. It is working as expected. So that is how we work now. But only the thing is that if I have to change uh, something for the scaling, I have to go and change in all the blocks where this particular logic is implemented. Because if and we have to do a testing for all the blocks. But if I go in this particular application, okay, where I'm inheriting the scaling block, so a scaling block remains as it is. I'm inherited those scaling block into pressure and temperature. Okay, functionality I will get same. There is no change in the functionality. Okay, so in both the case, functionality what we need is working as expected. Only the thing which is helping us here is we don't, if for example I change the raw max, so I change only in the scaling block, I don't have to go and change in each other blocks. So the code reusability is there, the maintenance of code is less. For any change I have to change only at once, other part it will automatically get reflected. And the most important thing is it reduces the development effort. And also for any changes, as our main class is already tested one, I do not have to test it every time. Only the code which is changed in the child classes, those code only I have to test. So the testing cost also got less. Okay, so what benefit we are getting? Less development cost, less testing cost, and less maintenance cost. So that is the benefit of having the inheritance utilization or the object oriented programming approach. So there's no difference apart from that. Okay, and that is the one of the main difference which is created by using object oriented programming. So what are the major benefits we get when we utilizes the inheritance? So first thing is the code reusability. Okay, so when a class inheritance or derives another class, it can access the functionality of the inherited class. That is the first thing. So how exactly it do? So like the FB sensor we have defined. So this is the parent class. How we are calling it using super function. Okay, so it is inheriting all the properties of the parent class. So when I call that in the ladder, it is having all exactly the same structure, correct? The reusability and the testing, so this get reduced because we have already tested the FB sensor class, so I don't have to retest it. Only what I have to do the testing is the extra feature which I have created in the child classes. Existing code get reused. Okay, now inheritance make the subclasses follow a standard interface. So this is the way we have to utilize. So I will be going more deeper into it. So this is the very basic of the inheritance, because in the next chapter I will be covering how exactly we can utilize interface, what is the abstract class, what are different kind of inheritance which we can utilize in our PLC programming. So that's all for now. and I will be catching you in the next video with more detail of the object oriented programming. Thanks for watching. That's all for this video. See you in the next one.